our content is going to be like CCNP plus like NRC and ENCORE. So earlier, this whatever we are going to cover in NRC, earlier it was there in route section of CCNP. Earlier we had an exam called CCNP route, and everything that we are going to cover in NRC, it was originally there in the route part of the content. And the ENCORE is more like the written exam for the CCIE. So it contains a lot of things that you should know before you can attempt your CCIE written exam. And once you clear your CCIE written exam, you can go for CCIE lab exam. Okay, so we are going to cover the content in a mixture because a lot of content is overlapping. Not everything, but I will just show you in a moment. I will show you in a moment that a lot of content is overlapping. So we are going to cover both of the content at the same time. Like, for example, if I start a protocol, I will complete that protocol from the NRC point of view as well as the ENCORE point of view so that we don't have to start with that protocol again. In NRC content, we have again some limited thing. In ENCORE content, we have some limited thing. And overall, when we cover both, we will have sufficient knowledge to, in fact, clear the NRC and ENCORE exam as well. Okay. So the content that we are going to cover in NRC is this one. This is what we have to cover in Enterprise Advanced Routing and Services. This is the full form for the NRC. And if you want to attend the exam, this is going to be a multiple choice question exam, 90 minutes in total. And this thing you can read. But eventually this exam focuses completely on routing section of our content. As you can see, the first unit that we have to cover is layer 3 technology. In the layer 3 technology, which covers approximately 35% of our entire content, is going to focus on administrative distance, AD value, route map, loop prevention, redistribution, summarization, policy-based routing, VRF, BFD, EIGRP, OSPF, BGP, everything regarding routing is there in the first 35% of the content. So first 35% of the content in our NRC is focused completely on the routing part. And then we have, once we are done with that, once we are done with our routing section, like once we are done with our routing protocols such as EIGRP, OSPF, BGP for IPv4, for IPv6, additional concepts such as redistribution, policy-based routing, summarization, and everything. Once we are done with that, we will focus on VPN technology. In the VPN technology, our focus will be how can we connect our different branches, such as branch 1, branch 2, branch 3. We have different branches, branch N. How can connect with different branches all together using any technology such as MPLS, such as VPN, DMVPN, and all. How can we connect all these branches, for example, to headquarters? How can we connect all these branches to the data center network? So different service providers we can utilize to connect all these branches together and also to the headquarters and data center. And different technologies we can actually use for the same. So when it comes to remote site connectivity, we are going to talk about the VPN technology. In the VPN technology, we are going to talk about remote site connectivity. We'll talk about how or what technology we can use for remote site connectivity to connect our headquarters branches all together. Once we are done with that, then we will focus. This is 20% of the entire content. So 35% earlier, 20% from here, it is going to be 55% in total. And then we are going to focus on security, infrastructure security. So once we have designed our network, once we have configured the routing protocols, once we have ensured the reachability and everything, once we have done all of that, we will focus on securing our network, such as in between two routers, when we configure a routing protocol, we must also configure some sort of authentication. so that these routing protocols do not share the route information unless the other device is properly authenticated. Okay, so we will focus on that part as well. For example, this one, the routing authentication part. We'll focus on access control list, standard access list, extended access list, additional security features such as control plane policing feature. How can we limit what type of traffic can go towards the CPU of the device? How can we limit that? All that thing we are going to cover under infrastructure security, which is again going to cover 20% of the entire content. And the last 25% of the content is going to focus on different services that we can configure in our infrastructure. So last 25% content is going to focus on infrastructure services. So console, NVTY, Telnet, SSH, FTP, TFTP, SNMP, DHCP, SLA, NetFlow, DNS Center, all that we are going to talk about. At the very end, we will focus on the services part. So total 4 units are there in our NRC content. And you will notice a lot of content from our NRC is also covered in ENCORE. This is the official content from ENCORE. This is the official content from Enterprise Core, which is a 120-minute exam. 2 hours it is going to take for the exam. And if I scroll down, this content is divided into, again, a few parts, as you can see. Total 6 parts we have to cover here. You will notice a lot of part is overlapping, but a lot of part is completely new. For example, here we also have some switching part. Here we also have some wireless part. Here we also have some automation part. Okay. So explain the design principle in an enterprise network: 2-tier design, core distribution, network access, a 3-tier design, core distribution and access layer, 2-tier design where we just have the core distribution layer and the access layer. How can we plan the fabric capacity, high availability, HSRP, VRRP, GLVP, stateful switchover. So this is from the wired network infrastructure point of view. Then how can we design our network in the wireless infrastructure, analyze the design principle of wireless local area network design. So how can we deploy our wireless network? What are the options that we can go for, like centralized deployment, distributed deployment, controller-less deployment, controller-based deployment, and all. Location services in WLAN, all that thing we have to talk about. What is the difference in on-premise deployment and cloud infrastructure deployment? What if I deploy some particular device onto the premises, onto the local location, and what if I deploy the same device on the cloud? What is going to be difference in that? Then we have SD-WAN design solution, SDA, software-defined networking. Software-defined is a part of software-defined networking, software-defined wide area network, modern-day solution to manage all the routers that we connect to the internet, to the WAN. All the routers that we connect to the WAN, how can we manage all those routers from a centralized point? How can we design everything from the SD-WAN point of view? Same thing, we have the SDA one. How can we manage our enterprise network? How can we manage our enterprise network from a centralized point using DNA center appliance? Okay, how can we manage all that? This is the software-defined networking solution to deploy the WAN and the LAN in an enterprise network. So what controllers are used there, how traditional WAN is different from the SD-WAN, how the traditional campus infrastructure is different than the modern day campus infrastructure. All that we are going to talk about as a part of this thing. Again, this is not there in our NRC. This is not there in NRC. This is not there in NRC. Quality of service. We want to apply some preference. We want to apply some preference to certain application traffic as compared to the other application traffic. So we can actually how can we apply different quality of service thing? None of this part is there in the NRC content. It is purely in the ENCORE one. Okay. Then switching. This 1.7 focuses on switching. What different type of switching structure, what type of tables switches have, what is the difference between routing table and the MAC address table, what is FABE, what is REBE. All that is basically switching and routing concept that we will have, that we will talk about. Fine. Then we have virtualization concept. 10% of the content in ENCORE focuses on virtualization. How like different server virtualization technique. For example, what is virtual machine? What is hypervisor? Type 1 hypervisor, type 2 hypervisor, how switching and everything happens in that virtual environment. What techniques are available in Cisco hardware, such as router, when it comes to the virtualize the deployment. So configure and verify data path virtualization techniques such as VRF, GRE, IP tunneling. A network virtualization concepts such as Lisp and VXLAN we will talk about. All that comes under the virtualization section, which is going to cover 10% of the entire content. This is not there in NRC. This is not there in NRC. This is there in NRC. Then layer 2 focuses on switching. So Ether channel, STP, trunk and everything. This focuses on switching part. This focuses on routing, all the concepts. Compare routing protocols such as EIGRP, OSPF, configure and verify OSPF environment, configure and verify BGP, indirectly connected neighbor. Very limited content is here. Very limited content is here, but actually this content is completely covered in NRC. This is not covered in NRC. NRC does not focus on the switching part. It is pure routing part. So this is the overlapping content with the NRC one. Once we have done NRC, we will not need to do this. Everything in NRC will cover here. The wireless, like the wireless concept, how the frames move, how the bits move in the wireless architecture, access point, the wireless LAN controller, all that concept we have to talk about from the wireless design point of view, from wireless data forwarding point of view. All the concepts such as radio frequency, signal to noise ratio, SNR, noise, channels, design, WLC, access point, antenna, different types of antenna and everything. We have to focus on the wireless part. Then in the IP services, we have NTP, we have NAC, HSRP, VRRP, all that thing, multicast protocols such as PIM, IGMP and all. This is going to there in the IP services part. Again, for example, this content is overlapping. That's it. Only this content is overlapping with the NRC one. Then we have network assurance, monitoring. Here, we will talk everything about monitoring. How can we use debug, conditional debug, trace, SNMP, syslog, remote syslog for remote login, netflow, span, rspan, DNA center, netconf, restconf. Almost like if you leave this DNA center part, netconf, restconf part, everything else is again overlapping with the NRC content. In fact, I would say the content in NRC is sufficient enough to cover everything on here. Then we have security. Just basic security part is overlapping with NRC, like access list, control plane protection, configure the password on the lines and everything, authentication, authorization, and everything. This is what we have already. This is completely overlapping with the NRC one. This is completely overlapping with NRC. But for example, here this is completely new. REST-based APIs, for example, and the EEP, WebBot, PSK, pre-shared key, and everything. All that thing is completely new. It is not the part of NRC. Okay, this, for example, this entire thing is completely new. It is specific to ENCORE. Okay, threat defense, endpoint security, next-gen firewall, TrustSec, MAC, TrustSec, MACsec, network access control using .1x, MAB, WebAuth, all that. Describe, not configure, just describe. So theoretically, we will talk about all these features. Practically, we will configure extensible authentication protocol, WebAuth, and pre-share key for the security. And at the very end, we have the different automation feature where we will try to learn how can we intercept the basic Python component and scripts. We don't have to necessarily know the entire coding for Python. We just need to know if a Python script is written, how can we actually intercept that Python script and see what's going on? How can we construct a valid JSON encoded file? Yang the data model, DNS enter, how can we place variety of API calls to our DNS center, and we manage to retrieve a variety of information or to configure variety of aspects of the network. How can we interpret this response that comes from the DNS center and the vmanage, and we can extract the useful information out of that. How can we configure some templates to automate configuration, troubleshooting, and data collection? Chef, Puppet, and Ansible tools, Salt Stack, these tools that we have to talk about, at least theoretically, what is the difference in between these agent and agentless orchestration tools such as Chef, Puppet, and configuration management tool, basically. What are the differences in between these? This is going to be the 15% content. Again, this is not overlapping. So you might see a little bit of content is overlapping, but a lot of content is not overlapping. It is completely new. So when we start our content, I will refer to both of the things. For example, once I start EIGRP, or once I start OSPF, once I start BGP, I will cover EIGRP, OSPF, BGP that much that we will not need any discussion for the ENCORE class. Everything from here is already going to be covered in the NRC one. Switching fundamental. What exactly is switching? So forwarding the frames based on the layer 2 address is known as switching, which means like, let's say we had to send the traffic from device A to device B, and we have connected these two devices with an intermediate device. It could be any intermediate device, I do not care. But if that device is capable, or if device is forwarding the packets, if this device is forwarding the traffic from one interface to other interface based on MAC address, based on a destination MAC address or a layer 2 address, which is also known as the MAC address, then that is what we are going to call as switching. So switching is forwarding the frames based on destination MAC address. Why we call them frame? Because it is the protocol data unit for the data link layer, and switching is a process that happens at layer 2. So that's why we are going to refer this traffic that this device has received as frame. So forwarding of the frames based on the layer 2 address is known as switching. Layer 2 address is also called the MAC address, and MAC address is a concept of data link layer. That's why switching is also a process of a layer 2. So forwardings of the frame on the basis of the layer 2 address is called switching. And all the devices that forward the traffic, forward the frames based on the destination MAC address, they are called layer 2 devices. Most commonly utilized layer 2 devices are layer 2 switches. So any device that is capable of receiving the traffic on one of its interface and forward it out of the other interface based on destination MAC address, that device is said to have the layer 2 switching capabilities. And generally, you will see layer 2 switches coming under this category. Layer 2 switches come under the category of these type of devices. However, we also have in our production environment, we also have some layer 3 switch, some multi-layer switches. Sometimes people refer layer 3 switches as the multi-layer switches. Like there is since layer 3 switch can forward the traffic based on layer 2 and layer 3, both the addresses, means like MAC address and IP address. So that's why we say that these layer 3 switches, they act multiple layers. They work at the data link layer. They also work at the network layer, because they are doing both switching, they are doing the routing. That's why we can put them in a separate category. We can put those devices that can forward the traffic based on both layer 2 and layer 3 address. We can put them in a different category, and that category is called layer 3 switch. So we have a device called layer 2 device, layer 2 switch, a device that forwards the packets, forward the frames actually, based on pure layer 2 address, which is MAC address. A device that is capable enough of forwarding the traffic based on layer 2 and layer 3, both the types of address. Basically, that device is capable of performing routing and switching both, but it will do more switching, less routing. It is not designed to perform routing dedicatedly. Routing is just like more like as an additional capability for the same. Main function of that device is to perform switching. So that device is what we call layer 3 device, layer 3 switch, that device we call. Since these devices, they work at multiple layer, people basically generally refer to them as multi-layer switches, which might be true, from the conceptual point of view. From the conceptual point of view, it might be true, because the device is working at both the layers of the OSI TCP/IP model, data link layer and the network layer. But when it comes to the multi-layer switches, the true nature of the multi-layer switches, the true property of the multi-layer switch, a device is set to be in a category of multi-layer switch when it also can include the layer 4 addresses in its forwarding decision. And the layer 4 address is what we call the port numbers. And so let's say there is a device, there is a switch that can perform packet forwarding based on layer 2 address, perform packet forwarding based on layer 3 address, and also can include layer 4 address in its packet forwarding process, in its data forwarding process. Then that device is going to be called as multi-layer switch. And generally, this thing means that that particular device is going to be capable of running NAT, or network address translation. Like the term multi-layer switching, the definition of the multi-layer switches or multi-layer switching might be different based on vendor to vendor, but almost in all the vendors, it will have the capability of NATing. Because when we perform the NAT, we will see the use of the TCP UDP port numbers there. Maybe that switch is capable, that multi-layer switch that we are talking about, maybe that multi-layer switch is capable enough to load balance some traffic going towards a particular port number out of one interface, some traffic going towards a particular port number out of other interface, some traffic going towards another port number 2021 maybe out of the other interface. Maybe that multi-layer switch is capable enough of performing load balancing based on the destination port number, or it can include those destination port numbers in performing the packet forwarding decision. That type of switch is what we are going to call as multi-layer switch. Questions? Let me know. Any question you want to ask?
No, it's clear, Mr. Surendra, but if you can speak a little bit slowly, it's better for me and for my understanding. Yeah, because mashallah, your English level, it's high level. My English level not same as you.
No problem at all. No problem at all. I will speak a little bit slowly.
Yeah, all previously all clear. There's no doubt. Thank you.
So again, just to revise, forwarding of the frames based on layer 2 address is known as switching. Any device that can forward frames based on layer 2 address, they are known as layer 2 devices. A typical example for layer 2 device is a layer 2 switch. Apart from the layer 2 switch, we also have in the market layer 3 switches and multi-layer switches. Layer 2 switches can forward the packets based on destination MAC address. Layer 3 switches can forward the packet, or the packet means normal packet. Packet doesn't mean network layer packet. Packet just means just a normal term for the packet, the traffic. Layer 3 switches can forward the traffic based on MAC address and IP address both. And the multi-layer switches can forward the traffic based on MAC, IP, and they can also include TCP UDP port numbers in their forwarding decision. Typically, when we go for the layer 2 switches, a layer 2 switch is just an Ethernet switch, is just a multi-port network bridge. So before the switch, we had a device called bridge. Okay, we had earlier to this technology called switch, we used to have a device called bridge, which is represented by this type of symbol. Like look-wise, by the looks, you will not be able to find the differences. It will just say a bridge, but the hardware architecture will look kind of similar, just like we have in the switches. But the functionality of the bridge and switch, and also the functionality of the bridge and switch is quite synonymous. Like a lot of similarities are there in functionality of this bridge and the switch. So we can say switches are successor to the bridges, or bridges are predecessors to the switches. Means more like switch is a next, like switch is a switch came one generation after than the bridges. Bridge is more like an old generation device. So an Ethernet switch is just a multi-port bridge that uses hardware address, which is called MAC address, to process and forward the data at the data link layer of the OSI model. A commonly utilized, very commonly utilized layer 2 switch is 2950 series switch and 2960 series switch, which just looks like this. By the looks, you can see that the layer 2 switch looks like this. It is a 2960 series Catalyst switch platform. Catalyst was a company which was acquired by Cisco, and it was more like named as Cisco Catalyst. So this Cisco Catalyst switch that you see here, it is 2950 series Catalyst switch platform. Now, so layer 2 switches can only forward the traffic based on destination MAC address. However, if you go for a layer 3 switch, layer 3 switches can also process the data at network layer by additionally incorporating the routing functionality, which means a layer 3 switch can forward the data based on destination MAC address as well as the destination IP address. Basically, the layer 3 switch can perform switching as well as routing. It comes onto the configuration. Have we configured IP routing command onto that device or not? If we have configured IP routing command, it will also act as a router. If you have not configured that command, it will act purely as the switch. So these switches can make their forwarding decision based on both MAC address and IP address, and commonly utilize the layer 3 switches switch platform are these 3550, 3560, 3750, 3760. These are very commonly utilized the layer 3 switch platforms. Okay. Multi-layer switches or layer 4 switches, people they say like layer 4 switches or multi-layer switches. While the exact meaning of term layer 4 switch is vendor dependent, it almost always starts with the capability of NAT. Remember, layer 3 switches cannot include port numbers in their forwarding decision, which means if to make a forwarding decision, port number is required, layer 3 switches cannot actually do that. They cannot consider port numbers in their forwarding decision. Means layer 3 switches, you will not be able to perform netting on those switches. They lack, layer 3 switches or layer 2 switches, they lack the necessary hardware required to support this netting concept. Or so the multi-layer switches will have the capability to perform netting in the network, and they may add some type of load distribution based on TCP sessions, and they might also support advanced quality of service capabilities. So this is a multi-layer switch. Traffic arrives for different TCP application. Some traffic might go out of this interface, some traffic might go out of this interface, some traffic might go out of the other interfaces. So multi-layer switches are actually different than the layer 3 switches. There is a difference between layer 3 and multi-layer switches. However, in most of the cases, people assume that the layer 3 switch and multi-layer switch is exactly the same, which is not the case. Layer 3 switch and multi-layer switch is actually, both the concepts are actually different. Fine. Now, in modern day network, in today's network, you will see this concept of layer 2 switch, layer 3 switch, multi-layer switch. The multi-layer switch looks something like this. Multi-layer switches can also look like this. They like it could be a like 4000 series switch, 5000 series switch. It could look just like this, or it could be a rack. It could be a rack type of structure. This is an outer chassis, and inside this chassis we have the power supplies. Okay, we have some slots. These are called slots, where we have inserted line card, which we say tray of port, this right here, and soup card, which is called CPU, soup card or supervisor engine, which is just a tray like this, but it includes CPU in it. Typically, in these switches, everything is on the same motherboard. Like it's the motherboard. In the same motherboard, we have the ports and we have the CPU. We have everything, RAM and everything is on the same motherboard. But here in the multi-layer switches, we have a dedicated slot, a dedicated card for ports, for interfaces. These cards that have interfaces in it or ports in it, they are called line card. And the soup card stands for supervisor engine. Supervisor engine includes again a tray, but in that tray there will be CPU and some other additional ports that might be required to support it. But it will be a dedicated, hardware that we can actually insert onto those multi-layer switches. It looks something like this, just in case if you want to know. It looks something like this. For example, like this. So you purchase this, okay? You purchase this from Cisco or from wherever you want to, and you can just insert this slot that you have here into this switch that you see here, right here, into this empty slot. You can insert it right away. So this is how the soup card, this is what we call soup card. Soup card stands for supervisor engine. There are some ports in it that have some specific purpose. There is a console port, there is some USB port and everything, and the flash and everything, and we can insert this into that multi-layer switch platform like this. So this is actually an image of a multi-layer switch. This is how it looks like. It is just which one is it? It is 6509, 6500 series switch platform with 9 number of slots. You can count one, if you want to count 1, 2, 3, 4, 5, 6, 7, 8, and 9 number of slots. It is a 6500 series switch with 9 number of slots. In there, some slots are reserved only for supervisor engine, and some slots are reserved for port. Means in some slots, you can only add ports In some slots, you can only and only add supervisor engine. You cannot actually swap it. You cannot connect your supervisor engine CPU into these slots, and you cannot connect these line cards into this supervisor engine slot. And you can purchase any line card. You can purchase a line card that has an Ethernet port, fast Ethernet port, gigabit port, fiber optical port. You can purchase these line cards as per your requirement. So if you see like a line card, just search line card here, and you will see that this is how the line card looks like. This is how you just just insert that line card into the switch. It's more like a hot swappable. It's a hot swappable device. That means even if the device is powered on, you can remove that slot and you can add a new one if you want. Completely modular. You have to purchase everything. You have to purchase all these things you have to purchase. And basically you have to purchase the outer chassis, you have to purchase the fans, you have to purchase the power supply, you have to purchase the line card, purchase the soup card, everything. Once you have purchased, you have to assemble it at your location. And it's not like all the 6500 series devices will look like that. They also come like that, like these, like normal devices. They also come like a normal device, not a rack type of the structure, just a normal device is also there. So 6503, for example, this is a 6503 where we have 3 slots. This is 1, 2, 3, 4, 5, 6, 7, 6507. And these are just normal 6500 series devices. So we can have both the type of device. We can have a device that is like this, or we can have a device that is like this. And both are going to be considered as a multi-layer switch because they have the necessary hardware to support multi-layer switching capabilities, such as NAT and everything. So multi-layer switches, first thing, multi-layer switches have the capability to perform NAT. Second, they might also be able to load balance or distribute the load based on TCP sessions. They might be able to perform, they might be able to do some additional quality of service. They might possess, they might have additional quality of service capabilities. So we have line card in the multi-layer switch. We have a line card, which is just another way of saying that we have a tray of port, and we have a soup card, which is another way of saying that we have a dedicated tray for CPU. We cannot put a line card in a soup card slot. We cannot put a soup card in the line card slot. And what slot is going to be used for the line card? What slot is going to be used for the supervisor engine? It is fixed. No one is going to ask you, but it is fixed. If you want to know which slot is fixed for which one, you can always refer to the data sheet. You can always refer to the data sheet. Like, for example, a 6509 data sheet. 6509 data sheet. You can just look up the 6509 data sheet, and in that it will tell you that slot number maybe 5 and 6, they are reserved for supervisor engine. Fine. Now, this supervisor engine is very important component in your multi-layer switch. Supervisor engine means CPU. Due to any reason, if this supervisor engine goes down, CPU goes down due to any reason, your entire switch will go down because all the computations and everything will be done by that supervisor engine, that CPU itself. So if you only have one supervisor engine into your switch, in that case, if that supervisor engine goes down, it will be a problem. That is why some switch platform, they support multiple supervisor engine. Like in the same switch, we can have two supervisor engine, we can have two CPU attached. One will perform processing, one will be active, one will be standby. So if the active goes down, the standby one will start acting as the active one. Okay. Questions, let me know.
Thank you. Everything clear. Thank you.
Okay. But nowadays, this thing that we are studying, that 2964565 is a multi-layer switch. This thing that layer 3 is 3550, 3560, these are layer 3 switches. This thing, you know, I would say this is just an old thing. Like this is nowadays, things have gone like a little bit different in modern day network. In modern day network, it's not like that. In modern day network, this concept is not like this. In a modern day network, like if you have studied CCNA, you must be familiar with that 3-tier hierarchical model, where they suggest that if we have to design a network, first of all, first layer that comes into the picture is called the access layer. Access layer is the layer where our end users are connected. Then we have something called a distribution layer. Distribution layer is the layer where we connect our access layer devices, like that. Like this. And then we have also something called a core layer. And then it can go to the campus edge layer, where we have the routers, and they might be connected to the external network such as internet. Something like that. Now, this thing, typically switching actually happens right here. Switching happens right here. About here, routing happens, like right here, routing happens. Like we will configure the IP address, routing, OSPF, EIGRP, whatever protocol, so that we can connect our campus network to the internet and all. Here in below the distribution layer, we will have the concept of VLAN, VTP, DTP, STP, whatever different concepts, trunk, access port, inter-VLAN routing, everything will be there in between access layer and distribution layer. Typically, a distribution layer device becomes the default gateway for the access layer devices. Nowadays, things are moving towards software-defined networking, where Cisco recommends that you should be able to manage the entire campus infrastructure, campus area network from an appliance called DNA Center. They have a solution. They have a solution called DNA Center or DNAC, from where you can actually manage your entire LAN campus area network in a centralized way. It gives you a lot of facilities such as network automation, centralized management. We can push the configurations from there. We can do a lot of things from that appliance. Now, if I want to manage all the switches of my campus area network from this centralized appliance called DNA Center, this appliance, this hardware appliance, has to be reachable to all these devices. To all these devices, this appliance has to be reachable. And if I have to make this, for example, switch reachable to this appliance, we have to configure routing and everything. That means our layer 3 boundary, which was earlier here, it is now going to be shifted right here. That means distribution layer is no longer in a modern day network the layer 3 boundary. The layer 3 boundary is right at the access layer. Basically, the routing will not happen between a distribution layer and the above. It will happen all the way from the access layer to the distribution core and everything. So what we are going to do, we are going to configure these interfaces with the IP address, perform the routing, create some loopback interface, make it reachable with the DNS center, then discover those devices. Once the DNS center is aware of all these devices, it can manage all those devices from a centralized point. So nowadays, things are moving towards software-defined networking. So this concept of layer 2 switches, layer 3 switches, multi-layer switches, it's not, that much valid in modern day network as actually it was earlier. In fact, these devices Cisco has replaced as well. These devices 2950, 2960, Catalyst the 2000 series platform, 3000 series platform, 4000, 6000 series switch platform. A lot of switch platforms you will notice that Cisco has replaced with a new series of switches compatible with software-defined networking. Because Cisco actually knows, because Cisco actually knows that either today or in near future, things will go towards that software-defined networking anyway. So that's why they have made new switches compatible with our new industry standard software-defined networking as well. And these switches are Catalyst 9000 series switches. Earlier, people used to identify the layer 2 switches by the number 2. Earlier, people used to identify the switches by the number, so layer 3 switches by the number 3. So if it has 2 in its name, it will be a layer 2 switch. If it has 3, it will be a layer 3 switch. If it has 4, 5 and above, it will be a multi-layer switch. But nowadays, that concept is actually not true. That concept is, I will show you just in a moment. What you have to do, all you have to do is to search, just search all switch product on here, just search. Just search all switch products Cisco. If you search that, all switch products Cisco, once you search that, you click on this link, you click on this first link, and you will see these are different type of switches that you can purchase. You can purchase a switch called blade switch, campus LAN switch to be connected as the access layer, campus LAN switch to be connected at the distribution and core layer, compact switches, data center switches, different network management switches, small businesses and everything. Basically, these are the types of switches that you can purchase. At the moment, we are interested in access layer switches, core and distribution layer switches. So if you notice, you do not see that 2950, 3750, 3550, 3560. You don't see that nowadays. It's all about 9K, 9K, 9K. We still have 3650. There is a reason for that. We still have 2960. There is a reason for that. But you do not see those 35, 37, those 3560 and all that. Not in here in the campus LAN switches or core and distribution layer switches. Modern day switching network Forget about this. This is not a catalyst switch. This is a Nexus series switch that is used in the data center environment. We're not talking about data center. We are talking about enterprise network. In the enterprise network, we are going to connect normal switches like these catalyst 2000 or 3000 series switches. But nowadays, it's all about 9200, 9300, 9400. Somehow, this is equivalent to Catalyst 2000 series switches. This is equivalent to Catalyst 3000 series switches. This is equivalent to Catalyst 4000 series switches, and then so on. Okay, 6000, 5000, and all. So, however, they are a lot improved. They are a lot improved. So, for example, if they say you have to connect a device at the access layer in your campus area network, go for 9300 series switch. In the 9300 series switch category, you will find how many number of models. You can scroll down. How many models are there? So there is 9300X. There is 9300X fiber, copper. Then we have high performance model, multi-gigabit models, and you can just zoom out a little bit, 1G, 10. Basically, you have a lot of, there are a lot of switches in their portfolio. Basically, they have a lot of switches in their portfolio. You see? What is specifications? What things you will get here? You can study from here itself. Or you can download the data sheet. You can read the data sheet. If you want to actually know about it in very detail, you can just download this data sheet and you can keep it somewhere. It will be very handy, and you can get all the information from here. Everything. You can get all the information from here, all the models, how much or what capabilities are there. Everything you can actually study from this data sheet. I'm not saying that we have to go through, but you have to know. You have to know that, for example, if your company asks you that, okay, what switch we have to actually purchase and use to entertain, like, let's say 5,000 number of devices. So you should know, actually. You should know what switch is going to be capable enough of doing that. So we are not going to go through the data sheet and all, but just to tell you the information, you can always visit the data sheet for a particular device, and you can get all that information from here. There are a lot of information. There are different models. You can see if you scroll down, there are different models here, and the documents and everything, product portfolio, everything you will find in this, for example, in this page actually. So based on your requirement, 40 gig interface, 1 Tbps. Once you do the stacking and everything, you get a throughput of 1 Tbps and all. And everything is compatible with DNS Enter, DNS Enter, DNS Enter, DNS Enter. Like I said, everything in nowadays in modern day network is about automation, programming, software-defined networking. So all of these switches are compatible with the Cisco DNS Enter software-defined solution. Okay, questions? Let me know. Anything? So nowadays, this is not there. This is, this thing like 2950, 2960. This is just to tell you that at some point of time, there were things that we can use this number to identify that this is a layer 3 switch. We can still do that. But if I show you, just quickly, I will show you. For example, I have put this 2960 into the layer 2 switch category because that's what people say. But if just in case, if I go there, all switch product, if I open the data sheet for 2960 series switch, if I open this data sheet, okay, let me show you one thing. Okay, go to the features, or just look up the data sheet. Let me show you one thing. So this switch is also going to be discontinued soon. End of life announced. For this switch also, end of life has been announced. Sooner or later, end of sale will be announced as well. So like This was released. End of sale, it will be on 2022, which is, I think, in a couple of months. What is this? Today is September, October. So in October 31st, approximately 2 months, this switch will no longer be sold. And in 2027, support will end for this switch as well. Okay, but anyway, this is the operating system that we can install on that particular switch. This is operating system that we can install on that particular switch. And if you go through this document, somewhere you will see that you can perform routing as well. Okay, you can see that that this device actually supports some routing, some basic level of routing as well. Okay. See, what is this? What is this? I put that switch in a layer 2 category. Layer 2 switches cannot perform routing. They can only make their forwarding decisions based on IP address. Sorry, MAC address. Layer 2 switches can make their forwarding decision based on MAC address only. So why this switch is now, we are saying that it is capable of performing routing? Because actually it does that. The operating system image that we are going to deploy on there, it has necessary hardware that it supports routing as well. So should we put it in? Now we should put it in which category? Should we put it in layer 2 switch category or a layer 3 switch category?
I think we can use for both of them, layer 2 and layer 3.
Exactly. So
by our requirement.
Yeah, this is incorrect, right? In that case, this is incorrect. I should not have put this in layer 2 switch category. We should have put this in layer 3 switch category because it can perform routing as well. So that concept, right? That concept that if the number is 2, it will be layer 2. The number is 3, it is layer 3. If the number is 4 or 5, it is layer 4. Sometimes it might work, sometimes it might not be that much accurate actually. But anyway, this layer 2 switch, layer 3 switch, this multi-layer switch concept that we have, all of that thing actually is nowadays, replaced by this Catalyst 9K series switches. 9200 series switches are almost exactly the same or have the same functionality capabilities as a Catalyst 2000 series switch. Catalyst 3000 series switch is almost equivalent to the Catalyst like this Cisco 9300 series switches. Same we have Catalyst 4000 to 94000 and all. So they made devices, they renamed the devices, they made it compatible with the Cisco DNA Center appliance, and they ask you to purchase those new devices nowadays. And also keep in mind, it's not a very cost effective, like these switches that you are going to purchase, they might cost you thousands of rupees, thousands of dollars. Then you can purchase these switches from the Cisco website, and then you can install these switches in your production environment. Basically, they are not that cheap. They are, even though they support a lot of functionality, and they are very much costly. They are a lot much like very costly. So any questions so far? Let me know.
No, Mr. Surendra, no, thank you.
Now we have, let's say we have still like 3 types of switches. A switch that can make its forwarding decision purely based on MAC address. A switch that can make its forwarding decision based on layer 2 and layer 3, both the addresses. A switch that can make its forwarding decision based on layer 2, layer 3, and layer 4 address, port number, and everything. The interfaces or ports that we have onto these switches, they also have some types. The ports on the switch ports, the switch ports, the ports on the switch or the switch ports, they also have some types. So on a layer 2 switch, all of its port will be layer 2 port. On a layer 3 switch, all of its port can be layer 2 port or layer 3 port, or we can have some as layer 2 and some as layer 3. One port cannot be both, of course. That's why I did not write both. One port can either be like layer 2 and one port can either be like layer 3. So if we have a 48 port switch, I can have 24 port configured as a layer 2 port, and I can have 24 port configured as a layer 3 port. I can have that. In a layer 3, in a multi-layer switch, line card that we purchase, if we have purchased the line card, a tray of port, and these ports are layer 3, these ports can be actually set as a layer 2 port or a layer 3 port. So we have, when it comes to switch port, there are two types of ports, like layer 2 port or layer 3 port. Layer 2 ports, always remember, keep in mind, layer 2 ports always work based on IP address. Oh, sorry, MAC address or VLAN, if I must say.
Yeah, layer 2 MAC address, layer 3
IP address. A layer 2 port must be assigned with some VLAN membership. If on the layer 2 port, VLAN membership is not assigned, that port will not be considered as functional. And if the port is a layer 3 port, IP address has to be configured there. If the IP address is not there, that port will also not be considered as fully functional. So a layer 2 port that we have on a device, let's say this is a switch. This switch is a layer 3 switch. And onto this switch, the 24 ports that we have onto this switch, the 24 ports that we have configured them as a layer 2 port. That means those 24 ports, they must be part of some VLAN. And let's say the rest of the 23 ports we have configured as a layer 3 port. That means on those layer 3 ports, we will configure some IP address. So layer 2 port is based on VLAN membership and layer 3 port is based on the IP address. Now, a layer 2 port can be converted into the layer 3 port by the command no switch port. And a layer 3 port can be converted into the layer 2 port by the command switch port. So if a port is a layer 2 port, we can convert it into the layer 3 port by the command no switch port. And a layer 3 port can be converted into the layer 2 port by the command switch port. These two commands, obviously, they are not applicable on the layer 2 switch. Why? Because on the layer 2 switch, all of its port will always remain as a layer 2 port. And we cannot change the layer 2 ports into the layer 3 port if it is a layer 2 switch. How can we validate? How can we validate if a switch port is a layer 2 port or if a switch port is a layer 3 port? To validate that, use the command show interface name and the switch port. If after using this command, you see switch port enabled, then it is a layer 2 port. If you see switch port disabled, then it is a layer 3 port. Now, my question is, let's say we have a layer 3 switch. This is a layer 3 switch. And this layer 3 switch that we have to maybe telnet, we have to maybe do SSH. We might have to configure some additional services on there. We might have to update the operating system. We have to upgrade the operating system, download, whatever. I have a PC connected there. This is a layer 3 switch, keep in mind. And if I want to access this switch, for any reason, for example, management, I can do telnet, I can do SSH. If I want to do telnet or if I want to do SSH, I will need an IP address onto the switch. And since it is a layer 3 switch, I can simply convert this port into the layer 3 port. I can assign with an IP address, and the same subnet IP address I will assign onto the machine, and they will be able to talk to each other, just like we do it on the router. Is that right? That makes sense, right?
Yeah, I think like this will happen.
Yeah. But how can we do the same for a layer 2 switch? If it is a layer 2 switch and due to any reason, I have to access it for maybe management purpose, maybe for anything. Maybe I want to do some configurations onto this switch and I do not have a console cable with me. I know that I can do telnet, I can do SSH, but without the IP address onto this switch, how can I do telnet and SSH? This port is a layer 2 port. This port is a layer 2 port. So obviously I cannot convert it into the layer 3 port. Why? Because it is a layer 2 switch. There has to be some mechanism.
I think we have to create a VLAN after assign IP on the VLAN.
Okay. So what do we call that in technical terms? What that thing is
inter-VLAN routing?
No. That term, the thing that you said, it is correct. But what do we call this whole concept that you just explained? What do we call that? Interland routing is when we perform routing between two VLAN. That is not
between two VLAN. Yeah.
So just to refresh that, in these type of scenario, I know that this particular port is part of VLAN 1, let's say, because you remember by default all the ports are part of VLAN 1.
By default there is 5 VLAN, one of them VLAN 1.
Yeah. So this port is a layer 2 port, and layer 2 port will always be part of some VLAN. So by default it is part of which VLAN? By default it is part of VLAN 1. Now, okay, fine. I know that since this port is part of VLAN 1 and I cannot assign the IP address onto this port, because then I have to convert this port into the layer 3 port, and it is not allowed. What I can do actually, I can create a layer 3 interface for that particular VLAN. A logical layer 3, not physical, a logical layer 3 interface for that VLAN, and that logical layer 3 interface for the VLAN is called SVI. Switch Virtual Interface. Okay, so basically what we say, we are going to create an SVI for VLAN 1. How can we do that? Interface VLAN 1 and then IP address, like that. Okay, then 10.1.1.1/24 and then no shut and everything, right? This is what we did. So I actually knew that this particular port is part of VLAN 1 So I configured an SVI for VLAN 1. I assigned that SVI the IP address from the same subnet that I have configured onto this PC. And then when I do the ping 10.1.1.1, packet will arrive onto this switch port. This switch port is part of VLAN 1. Have we created any SVI for VLAN 1? Yes. Since we have created the SVI for VLAN 1, the packet will be handed over to that particular SVI. SVI is configured with the same IP address that we are pinging. So that SVI is going to give the reply. Okay. Questions, let me know.
No, thank you. It's
Okay.
clear.
So it's fine. Like this, let's take a switch. This is a Catalyst 2960 series switch. I have a PC here. Okay. I connected this PC with this switch. Onto which interface I did the connection? Let me show you. I connected this on FA0x1. Okay. Here I have configured. You must be familiar with this packet tracer, right? I don't have to explain this packet tracer.
Yeah, I already familiar with this.
So I have configured the IP address on the PC to be 192.168.10.100. And now I want this PC to be able to access this switch, maybe for some configuration or management purpose. So I will go to that switch. I will go to the CLI and I will check that PC is connected onto which interface. The PC is connected onto this interface. This interface is FA0x1 interface. Is that interface layer 2 interface or a layer 3 interface? Show interface is FA0x1 and command switch port. Once you use this command, and if you see, I don't care what the result is. I only am interested at the moment is with this. If I see switch port enabled, that means this is what? This is a layer 2 interface. And if it is a layer 2 interface, it will be configured with some VLAN membership. By default, it is what? By default, it is VLAN 1. We can also validate that by the command show VLAN brief. If you use that show VLAN brief command, you will see that FA0x1 is part of that particular VLAN. Now, I know that this interface I cannot convert into layer 3. Why? Because let us consider that it is a layer 2 switch and it will not let me do that. Okay. But I know that that particular interface is a part of VLAN 1. So I can do this interface VLAN 1. Maybe you can give a description, whatever description you want to give. Maybe you want to give a description. Something like that. And then you can configure the IP address. Now make sure that you configure the IP address from the same subnet that you have configured onto that PC. That PC is part of 192.168.10 subnet. So I have configured an SVI, switch virtual interface, with the same subnet as well. Okay. Now in this software, you might also have to do no shutdown, but in the real time, you might not have to do. But in this software, you might have to do the no shutdown. Okay. This is what we call SVI, switch virtual interface. Now, if I go on this device, I go to the command prompt. I say ping 192.168.10.1. You will notice that you will get the reply. You will get the reply. And who is giving you the reply? You got the reply. Who is giving the reply? 100% this switch is giving the reply. And I can prove that. I can prove that. To prove that, I'm going to change the host name and I'm going to say line VTY0 password login. Basically, I have set up telnet. I have set up telnet here. Then I'm going to go on this device. I'm going to set telnet 192.168.10.1 and I will get the access of that switch. It proves that 192.168.10.1 was indeed that particular switch. So what happened when the traffic arrived onto this interface? This interface was part of VLAN 1. Traffic was destined to 192.168.10.1. So have we created an SVI for VLAN 1? Yes. Since we created SVI for VLAN 1, packet will be handed over to that SVI for further processing. And since the IP address is exactly the same 10.1, 10.1, you got the ping reply, you got the telnet SSH, you will be able to do that. That makes sense? Any question? Let me know. Anything you did not understand?
Yeah, thank you. Clear.
Okay. Now, what is the advantage?
But we didn't dot in the CCNA level such process.
We cover it like in some basic level. We don't go in that much detail, but we still somehow cover these basic things. Now, what is the advantage of this? What is the advantage of this SVI? What is the advantage of this SVI instead of converting this interface into layer 3? What is the advantage of that? I could have done this like that as well. See, I could have gone to that interface, FA0x1. I could have used the command no switch port, and then I could have directly configured the IP address there. Okay. It will work as well. It will work as well. So what is the difference? What is the advantage of using IP address on the SVI in comparison to this one? The advantage is, see, think about it. If I connect one more PC right here, okay, on the interface FA0x2, that interface is part of which VLAN? VLAN 1 by default. On VLAN 1, what subnet we have configured? 192.168.10 subnet we have configured. If I go on this PC, I configure myself 192.168.10.200. I configure myself with the IP address of 192.168.10 subnet, same subnet as the VLAN 1. I go to the command prompt, ping 192.168.10.1. I will be able to do the ping and trace again. See, I will be able to do telnet SSH from this device as well. Point I'm trying to make, I can connect a lot of devices. I can connect a lot of devices like this. Hopefully you understand. I can connect all of devices, and all of these devices are part of which VLAN? All of devices are part of VLAN 1. And if I configure the IP address on all these devices from the same subnet as we have configured in VLAN 1, I will be able to access this switch. Right? In fact, I can go on this switch. In fact, and what is this? What is this? What am I doing here?
You create DHCP
Exactly.
server.
Yeah, I configured a DHCP pool onto this switch to provide the IP address of this subnet to anyone who asks. Now tell me, this subnet is configured in which VLAN? VLAN 1. In VLAN 1, how many ports are there? All the ports are there. That means if anyone in VLAN 1 asks for the IP address, if anyone in VLAN 1 asks for the IP address, this switch should be able to provide it with the IP address. You see? Do you see this? See? Understood? Do you understand this? It's very simple.
Yeah.
Right? So we can facilitate a lot of services. Like I don't even need to configure the IP addresses on these. I already configured an SVI. The SVI had an IP address 192.168.10.1. Packet arrived onto this interface. This interface is part of VLAN 1. Have we created the DHCP discover packet arrived onto that interface? That interface is part of VLAN 1. Have we configured an IP address on? Have we configured any SVI? That interface is a layer 2 interface. That layer 2 interface is part of VLAN 1. Have we created any SVI for VLAN 1? Yes. The SVI that we created on the VLAN 1 has what IP address? It has the IP address from range 192.168.10.1. And the same subnet we have here in the DHCP. That means the device is going to, it is able to allocate the IP address from that DHCP pool to anyone who asks in that particular VLAN. I can do telnet, I can do SSH, I can do DHCP. Basically, I can do all these things just with the help of that SVI. I could have done the same by, instead of giving the IP address on interface VLAN, I could have just converted that interface into a layer 3 interface, and I could have assigned the IP address directly there. Should we do that? Of course, let's try to do that. Let me do one thing. Let me reset this switch. Write, erase, and delete, and reload. I deleted everything. I deleted everything. The switch will restart. Okay? Nothing is there. As you can see, nothing is there. Everything is gone. Now I could have done the same by this interface FA 0/1, no switch port, and then IP address 192.168. whatever. But for that, we have to use a layer 3 switch first of all. This is a layer 2 switch. In the layer 2 switch, we cannot use that command. That command is not available. So we have to use a layer 3 switch. Where is the layer 3 switch here? Just right here, we have a 3560 series switch. 3550, 3560. I'm going to use this switch now. I'm going to connect everything on that switch. Okay. I have connected everything onto that particular switch now. This is a layer 3 switch. Now, again, I went on that particular interface, FA 0/6, like that. Enable. Interface, FA 0/6, and no switch port, and IP address
no shut. See, this is the command that I use. This switch is allowing me to convert that interface directly into a layer 3 interface. Interface FA0/6, no switch port, IP address, directly, without any problem. And since I have the same subnet IP here, I will still be able to do ping, trace, everything will still be successful. What is the difference in both?
I think we can divide layer 3 switch by creating virtual interface.
Yeah.
Too many subnets.
Yeah, exactly. That's where I was coming. Now, if I have to do the same for this one, I cannot do that. I cannot do that. Because if I go on to that interface, which interface? Interface FA0/5. And if I say what? No switch port, I cannot assign the IP address of which range? 192.168.10 range there. Why? Because that IP subnet is already assigned with this interface.
Yeah,
that means what we have to do? We have to configure this in a different subnet. Then this will be a different, subnet, a different subnet, a different subnet, a different subnet, a different subnet. All of them will require a different subnet. So, which does not make any sense. But maybe this is the distribution. This is a switch that we have connected here. The bottom interfaces are layer 2 interfaces. The upstream interfaces going towards router, they are layer 3 interfaces. I can do that. This is part of VLAN 10. This is a layer 3 interface, IP address, completely fine. We can do that. We can do that sort of thing. Okay. Even though
Mr. Surendra, I have a question, please. If we have a switch layer 3 switch, and also we assign IP address on of these switch port, we have many port. All other port also we assign IP address. Which port we can manage layer 3 switch via?
Anyone. Like for example, see, you configured a different IP address here, different IP address here, different IP address here, different IP address here. Since all those IPs are on these devices, this IP will act as a default gateway, this IP will act as a default gateway, this IP will act as a default gateway, this IP will act as a default gateway. So even if you try to manage this switch via this IP address, it will work fine because you will send your all the traffic to this switch, and on switch everything is directly connected. So
there's no problem. Both of them working.
No problem at all. All you have to make sure that the IP address you are going to use, all these all these IP addresses that we have configured onto these switches, they are directly connected, right? They are directly connected onto that particular switch. And since they are directly connected, I can ping from here to these IP, this IP, this IP, this IP. I can ping all these IP addresses because this I have configured. For example, on here, I have configured this IP address as my default gateway. So I will send all of my traffic here. And once the traffic comes here, everything is reachable. So no problem at all. All you have to make sure, if you want to access a switch remotely, all you have to make sure is the IP address that you are trying to access is reachable. If that IP is reachable, it will work fine. Okay.
Yeah. Also in the switch layer 2 switch, also we have console port for direct.
Yeah, console port is available on all the devices, router, switches, firewall. Firewalls also come with a management port, from where you can configure an IP, configure the same subnet IP on your machine, and you can directly access that firewall, for example.
Yeah, I got it.
But at the end, the difference between an SVI versus a layer 3 interface is pretty much clear. An SVI, switch virtual interface, which is which is this interface VLAN 1. Okay, interface VLAN 1, IP address, no shutdown, and everything. I can have n number of interfaces in VLAN 1, and every of that interface will be part of the same subnet. But here, that's not the case. If I have converted this interface into a layer 3 interface, whatever subnet I have allocated here, I cannot use the same subnet on other place. Got it, right?
Yeah, I got it, Mr. Surendra. Thank you.
Okay. Now, apart from that, you know, this thing that you just did, right here, that you went on the switch port and you did the no switch port command and you tried to assign the IP address, and you thought that just by saying the no switch port command, switch actually converted that interface into a layer 3 interface. That's not the case, actually. That's not the case. It is just to how can I put it? It is just to fool you. It is just to fool us. It is just to fool the switch that I have converted this into the layer 3 one. In background, what happens actually? In background, what happens? Once we use this command, what happens in the background? Actually, now switch automatically, switch automatically reserves a range of VLAN. Remember the VLANs? VLAN, we have normal range VLAN. And remember, we have something called extended range VLAN, right? 4094, right? Now, this is just, you might think that this is just the normal range. This is just the normal range for VLAN. And it is actually, it is a normal range. But also, this same range VLAN is used here. Let me tell you how. When we use that no switch port command, automatically in the background, switch is going to create a VLAN for this port from this range. Any VLAN, it can choose. It chooses from like 1006. It will go all the way up to 4094. So for example, for this port, it will choose the VLAN number what? 1006. It will basically map this port with this VLAN. Okay. Basically, it will make this port part of this VLAN. We will not be able to see this. We will not be able to see this. But it will happen in the background. Then it will create an SVI for the same. Like it will create a interface VLAN 1006, and whatever IP you have configured here. For example, you configure OSPF, anything you configure related to IP, it will configure onto that SVI. First of all, it will create a VLAN, extended range VLAN, for example, 1006. Then it will actually put that port. It will map that port with that particular VLAN. Then it will create an SVI for that VLAN. And then it will configure all the IP related things onto that particular SVI. Don't you think this is exactly the same process that we have done here? All these interfaces, by default, they were part of VLAN 1. I just created an SVI for VLAN 1. I configured it with the IP address, no shut and everything I did. This process, don't you think is exactly the same as this process? The only difference is that in this VLAN, there is only one interface. And in this VLAN, all the interfaces are there. We could have done this. I could have created, specifically for this, I could have created a VLAN 99 I could have put that port FA0/5 in VLAN 99. I could have created an SVI for VLAN 99. I could have configured the IP address onto that SVI 99, same subnet IP here, and then ping and trace and everything, right? Exactly same thing happens in the background when we do this. Exactly same thing happens in the background. When we do this no switch port command, exactly same thing happens in the background. Switch is automatically going to create a VLAN from that range. It is going to put that port part of that VLAN. It is going to create an SVI for that. And all the IP and everything related command, it is going to actually configure there. And you will think that, oh, the port has been converted into the layer 3 port. While in background, this is what happens. Questions? Let me know.
No, it is clear, but in the layer 2 switch, we can assign multiple interfaces to, for example, SVI to one VLAN, yeah?
In layer 2 switch, we can actually, if it was a layer 2 switch, like for example, this one, since show IP interface brief, we have already configured, for example, here, we have already configured one SVI, right? We have already configured here one SVI. Here, where is that? Here. Let me configure that again. So configure terminal, interface VLAN 1, IP address 192.168.10.1, for example. No shutdown, like that. Now, if let's say 24 parts are part of some another VLAN. Okay, like VLAN 2. Okay. And interface VLAN 2, IP address 192.168.20.1 to 55.55.55.0, no shutdown. We can do all that. Like switches, we can create multiple SVIs on those layer 2 switches as well. But finally, when you check here, finally at the end, when you will check here, you will notice that some switch platforms, they do not support both the VLANs in up state. So one will automatically go in the administrative down state automatically. In a layer 2 switch, if we have, like, for example, in a layer 2 switch, we have 24 ports, part of one particular VLAN, and everyone wants to access that switch. So we have to create an SVI for VLAN 10, and rest 24 ports, they are part of another VLAN, SVI for VLAN 20, like that. So I will not be actually, like, I can create SVIs, but when I create this SVI, this might go down, or it might support a finite amount of SVIs, a limited amount of SVIs, and then it will not support furthermore. So that thing actually varies model to model. I have observed in 2950 series switch platform, if you try to, if you try to do a no shut on one SVI, the other one goes down automatically. So it will not let you, in fact, it will not let you, enable two SVIs at the same time. Questions, let me know. So this right here, I can show you that. In fact, I can show you that. I'm not sure if this packet tracer software supports that or not, but I can show you that. How can we check that? How can we check? I do not see, if I use the command show interfaces fast Ethernet 0/6 switch port. Now remember, let me show you why you should not use packet tracer. Show run interface, or show run, just do so show run. See, This interface is configured with no switch port command, configured with the IP address. That means this port is a layer 3 port. And if it is a layer 3 port, this command should show you switch port disabled right here. It proves that this port has been converted into the layer 3 port. In the background, the same process has happened that we have discussed. In the background, the switch has actually created an SPI for the same. The switch has created an SPI for the same VLAN and everything it has created for the same. So how can we validate that? Command is show VLAN internal users. This is a command that you can use to check where the VLAN is being used for internal purposes. This command is not supported in the packet tracer. You will see this command in a real-time switch or some other software, but this command is not supported in the packet tracer. What should be the result of this command? This will be the result of the command here. When you use this command, show VLAN internal uses, you should actually see. You should see that gigabit 0 by 0, where you have used that no switch port command, has been allocated with the VLAN number 1006. So it starts from 1006 and it goes all the way to 4094. If you want it to start, if you want that the number must start with 4094 and go all the way to 1006, we can use a command for the same as well. The command is VLAN internal allocation policy descending. Ascending by default means start from 1006 and go all the way to 4094. Descending means start from 4094 and go all the way to 1006. Meanwhile, for example, let's say VLAN 1008 is already in use. Maybe what we did, one of the port of that switch, we put in VLAN 1008. And then you do the no switch port command. This VLAN will not be used by the switch for internal allocation. It will use the VLAN number 1009, okay, for internal users actually. So if any VLAN is in use, for example, if any VLAN is in use, it will not, this internal allocation policy will not use that VLAN. And if a particular VLAN has been used for this reason, you will notice that you will not be able to create that particular VLAN. So when we use that no switch port command, what happens in background, switch reserves extended range VLAN from 1006 to 4094 for this purpose. Like what it will do, interface 1 by 0 by 1. Once we use the no switch port command, it will assign this port the VLAN membership from this range, 1006 to 4094. If the internal allocation policy is ascending, it will start from 1006. If it is descending, it will start from 4094. Then it will disable all the layer 2 protocols onto that port, such as STP, VTP, DTP. It will disable all those protocols onto that particular interface. We can validate which VLAN has been used by the switch in that internal allocation policy, for example. Now, if we try to create that extended range VLAN, we will get this error. Since that VLAN is already used, that particular VLAN is already being used by the switch in internal uses, we will not be able to create that VLAN. If we try to do that, it will say failed to create the VLAN, VLAN not available in the port manager, failed to commit the extended VLAN changes. And if you have already created the VLAN, switch will not use it for internal users. It will just skip that particular VLAN. Okay. Questions? Let me know. Let me show you that.
No, thank you.
Let me show you that. So I'm going to use a different software called ENG. Okay, this is the software that I'm going to use. This is a simple software that runs on VMware. So I have already deployed this ENG software on here. Once I, get this message, I can just log into that ENG software. I can log into this EU using Firefox or browser 192.168.1.130. I can just log in just like that. And then just like the packet tracer, I can use different nodes on here. Okay. It supports a lot of things. It supports routing, switching, it supports firewalls, everything. It supports all, like a lot of other vendors as well. Not only Cisco, but Juniper, Fortinet, HP, different vendors it supports as well. However, the only thing that we are interested in at the moment is switching. So I can go for this, or I can go for this switch, whichever we want to use. For the moment, I'm going to use this IOL L2 Advanced Enterprise switch 1 switch. I'm just choosing the image for that switch. Okay, just save. And I'm going to power this one. This software actually uses, again, the routers and switches, the scaled down versions of those routers and switches. So we will be able to run a lot of commands here. We will be able to run a lot of commands here. Okay.
Can I install this application, this software, or?
You can install it in your machine. What is the specification for your machine? How much RAM you have onto your machine?
8 GB.
That is enough.
And processor Core i7.
That will work fine. 8 GB RAM, you can allocate 6 GB for this one and 2 GB for your operating system. It will work fine.
Video to show me how can I install, how can
I will be able to do that. I will do that.
Okay.
Okay, so see, this is a switch. Same thing, like everything is same, like host name, switch 1, and everything is same. Just let me show you. Do show IP interface brief. You can see there are these much interfaces. Let me select any of this interface. For example, this interface. At the moment, show interfaces switch port. You can see by default, it is a layer 2 port. You can see here it says layer 2 port by default. So interface is switch port. It says layer 2 by default. And if I convert it into the layer 3, how can I do that? Configure terminal, interface, gigabit. What was that? It was 0 by 2.
No.
And I will say no switch port. And I can then configure IP address, whatever IP I want to configure, just like I did in the last one. Same thing. Same thing. No problem at all. Now here, actually, you will be able to see all those things. So if you, for example, here, let's use that command. You don't see anything. Show run interface gig 0/2. Show run interface, show run interface gig 0/2. It just says this. You do not see this interface in the VLAN list now. Show VLAN brief. You don't see that interface there. Gigabit 0/2, you don't see that there. That interface you do not see there. Because that interface is not a layer 2 interface anymore. That interface is a layer 3 interface. And let me show you the command show VLAN internal allocation or users. You see? Show VLAN internal allocation. You can see that that particular interface actually has been allocated with the VLAN membership 1006. Okay. And if I now try to create that VLAN 1006, it will not let me do that. It will not let me, configure that. It says we cannot do that. It says not allowed. Why? Because that particular VLAN is already in use. Port manager extended VLAN already in use by VLAN gigabit interface 0/2. So failed to create that VLAN, not available in the port manager. And if I, for example, create VLAN 1007, it will let me create that VLAN 1007. Okay. But if I say interface gigabit 0/3, no switch port, IP address, maybe for example, I want to configure a different IP address there, 192.168.20. Now you see the next VLAN that it had to use, was VLAN 1007, because 1006, it already used that. Next VLAN that it had to use was 1007. But since 1007, I already created administratively, you can use the command show VLAN internal users, and you can check that the next VLAN that it has used automatically is 1008. The point is, it does that automatically. I don't have to do anything. It does that automatically.
Mr. Surendra, this software, it is enough for our CCNP session?
Yes.
Or we need another?
Now, we can use the command VLAN internal allocation policy and descending. So that next time if you do interface, for example, gigabit 0/1, no switch port, next time when you do that, it will start from 4096. Show VLAN internal users. If you check that, 4094 means not 96. It will start from there. Again, it does that automatically. We don't have to do anything in it. This thing is also done automatically by the switch. So on switches, we can have physical interfaces such as these ones. On switches, we have like logical interfaces such as interface VLAN, which represents entire broadcast domain instead of representing just one particular device. It represents entire broadcast domain. For example, we can have interface loopback. It is also some sort of virtual interface. So different types of interfaces we can have onto the switches. Okay, any questions? Let me know. So this has been like how and what type of interfaces we have on these different types of switches. Now, since we know about all these switches, we are good to go with the design part. We are good to see, or we are good to see what type of interfaces we can have and design and everything. Like where should we connect with switch, layer 2 switch, layer 3 switch and all. We can talk about that in our next class.